Hello again. So we're going to do the binomial theorem where the form of a binomial is a plus b to the power of n, where a could be anything and b could be anything. Well, in this case, a is 2x and b is going to be y and n is going to be 3. It's actually pretty interesting. I did a very easy one. It's only got 3. You can check it at home if you want to. 4, 5, 6. You can do that. I'm not going to. But here's how the formula works. It's n factorial over n factorial 0 factorial a to the n b to the 0 plus n factorial over n minus 1 factorial 1 factorial a to the n minus 1 b to the 1 plus, and it keeps going, and the last term becomes n factorial 0 over 0 factorial n factorial a to the 0 b to the n. Let me just explain what's going on here. N factorial is just going to be on top. N factorial just means, you know, like 3 factorial would be 3 times 2 times 1. If it was, if n was 5, it would be 5 times 4 times 3 times 2 times 1. What's going on in the denominator is this term, n minus 1, the next one would be n minus 2, n minus 3, n minus 4, n minus 5, until you get to 0 factorial. You know, the last term will be 0 factorial. What's happening here is it goes from 0 factorial to 1 factorial to 2 factorial to 3 factorial, etc., until it, you know, reaches n, and n is 3. This one goes a to the n, and then the next one is, so it would be a to the 3, this one would be a to the second, next one would be a to the first, a to the 0. This would start as b to the 0, b to the 1, b to the 2, and then it would end on b to the 3 for this one. If the exponent was a 6, then you go to the b to 3, 4, 5, 6, 7, 8, etc. It's really quite easy. Let me show you something that makes a little bit of sense. Hopefully you'll find it not too bad, or not bad enough. N factorial over n factorial cancels to 1. B to the 0 is 1. So your first term is just going to be a to the n. Everything else is just going to... And your last term, n factorial over n factorial, is 1. A to the 0 is 1. So your last term is just going to be whatever b to the n is. So I already know, using this formula, that my first term is going to be 8x to the third. That I just know that for a fact. Simple as that. It's just your a term to the third. So 2x to the third is 8x to the third. If I continue, I know my last term is going to be b to the n, which is y to the third. After that, I just kind of have to fill it in, you know. Won't be too bad, but won't be too good either. So this is my first term. I've got a second. This is my b to the 0, b to the 1, b to the second, b to the third. So I've got 2 more terms to fill in. Well, let's find out. My next one is n factorial. So now here's where you actually have to do some work, which is 3 factorial over n minus 1 factorial, which is 2 factorial, 1 factorial. A to the n minus 1, so basically all that is 2x to the second, which is 4x squared, times b to the first, so times y. I'm going to need my eraser, because I don't have any room. Next one is going to be n factorial, that's fine, which is 3 factorial. Now what's happening is it turns into n minus 1 factorial. So it was 3 minus 1, which is 2. Now it's going to be 1 factorial over, and then this number keeps getting bigger, it's going to be 2 factorial. Then it's going to be a to the n minus 1. So the first one was a to the third, then it was a to the second, now it's going to be a to the first, which is 2x to the first, which is just times 2x. And then it went from b0 to b1 to b squared. Well, it's going to be y squared. Done. Finito. Now I can move on to my last term, which I already wrote before. So when I simplify this bad boy, I got 8x cubed plus 3 factorial over 2 factorial is 3. 3 times 4 is 12. X squared y. Next one is 3 factorial divided by 1 factorial, 2 factorial is just 3. 3 times 2 is 6. X y squared, and then plus y cubed. Notice what happens. X cubed, x squared, x to the first, no x. No y, y to the first, y to the second, y to the third. The only real difficult part about this whole thing is just figuring out these bad boys right here. The coefficients in front of the variables. I mean, you don't even really have to plug in the variables. All you gotta do is say, oh, once I know this, I'm good to go. So with that said, although it's a little confusing, go ahead and practice it on your own. I don't actually, well, I'm not gonna say that I don't memorize it. I mean, once you recognize the patterns, okay, the variables you don't actually have to sit there and memorize. But the factorials and a to the n and b to whatever power it is, that's, you should take time to memorize. And if your teacher allows you to use that on a test, the formula test, that's fine. If they expect you to remember it, just remember it. That's the only advice I've got there. Well, I hope that was helpful in terms of the binomial theorem. For right now, have a great day. Goodbye.